All right, let's take a look at topic number 17 here. So let me share my screen with you. All right, so topic number 17 is regarding to application of lines and angles. So the first few pages, it just, I would just write down, just point out some notations. I'm not gonna read through every one of these. So as we know, a line actually can keep on going forever. So in the pictures, we always see lines with arrows on both ends, okay? That indicates the line never ends. All right, so if I want to call this line, we will call them as line AB, and make sure the arrow on top, okay, actually goes on forever. All right, line segment is actually part of a line with two endpoints. That's the reason why when we draw our notations, okay, the line on the top doesn't have any arrow to it, so that indicates as a line segment. Now, ray is a little bit interesting. Ray is actually part of a line with one endpoint, the other end goes on forever. And what we use ray is two rays actually make an angle. Okay, so remember everything comes from lines, okay? So ray is part of a line. If I got two rays, that actually makes an angle. So for example, if I have something like a ray, let's call this ray AB, like the picture is drawing here. So let's call the endpoint A, and the other point on the ray is called a B. So let's say here comes another ray, and this ray is actually called ray A to C. So if two rays share the same common endpoint, which is called the vertex, then it creates an angle. All right. Now, as you can remember, line segments, you got to have line segments, okay, to actually create polygons or shapes. Line segments actually make polygon. It's a more official word. I just call them shapes. And our first polygon, as most of us remember, is three-sided. Three line segment makes a triangle. Okay, so we need line segment to actually make our polygons. All right, this word called the plane. If you're actually looking at the handout, this word plane is just simply referring to a flat surface, okay, with no thickness, any surface that's actually a plane. So last time when we mentioned things like square feet, the square tell me that geometrically is referring to an area. All right, so this is weird. A lot of people get confused. And when I say the word square, that means I have a shape of a square. The square is actually on a plane, but on this surface, it's actually two-dimensional. Okay, dimensional. It's very similar to the word plane, because when we go to a 3D model, let me bring up the topic 18. You know what? Not topic 18. It's actually another topic. Let me see if I can put up the volume. Cause I already maybe see if I got something up here. No, I don't think I got anything on my computer. Oh Lord, I'm froze. Anyway, any types of geometric figure. So if I would just kind of bring this over here, all right, just like a rectangular solid. Okay, this is actually 3D. 3D means three-dimensional. So when we have three-dimensional, that means there's actually three different surface, three different planes, okay, that's actually involved. All right. So you can actually look at this rectangular solid. Remember, just think of it, I'm looking straight down at it, not from the side, but looking straight down. The bottom piece is actually one plane. Okay. Now looking at it from the side, this rectangle that's facing us is actually another dimension. This face or this surface on the right side is actually another dimension. So that's the reason why a lot of times people rather use the word dimension than use the word planes. Okay, three-dimensional object actually has three different planes. Okay, but to have one plane, you got to at least be two-dimensional. Okay, so if I would draw a line, right now my line, as you see on my screen, is drew on a what? It's actually drew on a two-dimensional plane. Even though a line is one-dimensional, but it can only, I can actually draw it within a 2D. Y'all see how wide your screen is, right? And how tall it is. See, that's actually one plane, which is involved with two dimensions. Okay, so, you know, once in a while we'll see this word plane. Okay, so whenever you encounter this word in an application problem, just think of it like a surface. Okay, like a table surface. All right, parallel lines. We know two lines can parallel. That means they will never intersect. I want you to see the notations for the parallel lines. Okay, that's how we will indicate the parallel lines. All right, earlier I used the word vertex. Vertex is a common endpoint of two line segments or arrays. Okay, we use this word a lot, overly used in math, vertex. All right. An angle is a union of two rays at a common vertex. So if you actually look at this part, this particular picture, here I have a ray, okay, B to A, and I have another ray called ray BC. So when I put the two rays together with and sharing with the same common endpoints, then we can actually call this angle. The way how we name angle is the way how we read it. We can actually say this angle is made out of from ray A to B and then from B to C. So instead of saying the letter B twice, that's why we can simply just call this angle ABC. Now I can also read it the other way. I can say here I have a ray from C to B and then from B to A. So reading it the other way, again, rather than having two letters of B, I can just have one of them. So we can call this angle CBA as well. So there are different ways to actually read an angle. And the easiest way to read an angle is basically just call them angle B, where the vertex is, okay? So this is just different way to read an angle. We'll do that a little bit. All right, as you can recall, acute angles is where the angle at the vertex is actually less than 90. Greater than 0, less than 90. Obtuse angles is actually between 90 to 180. If it's exactly 90 degrees, we call them the right angles, which this is our symbol. This is key. You got to see this part. Okay, right angle, 90 degrees. So that's the reason why sometimes when we're talking about if two lines are perpendicular, well, without this symbol, without the right angle symbol, oh Lord, without the right angle symbol, you cannot say these two lines are perpendicular. In order to be perpendicular, you got to see that right angle notation. Okay. So obtuse angle is actually between 90 and 180. If it's 90, it's called the right angle. If it's 180, okay, that's actually considered as a straight angle, or sometimes we just say straight line. So whenever you see a straight line, you can think of a straight angle. This is just two rays look like exactly like a straight line. Straight line or straight angles will always be 180 degrees. All right, keep that in mind. Keep that in mind. I'm going through this very fast because a lot of people already seen this. All right, adjacent angles. Uh, Normally I just view the word adjacent angle as two angles, okay, as two angles on the same line. All right, that are actually side by side. Okay, adjacent, kind of think of as side by side. So let me draw a better picture. Um, I really want to get rid of this. Oh Lord. So let's say here I have a line. Okay, let's call this same way as line AC. And let's say here is a point B, and here is actually a line segment or array. Let's call it D up here. All right. So what I mean by adjacent angle is angle B. I'm gonna read from A. Angle from A to B to D. This angle and angle C to B to D, the one right next to it on the same line. So I want to point out, you see my marking here, this point and this point versus the ray one. Both of these marking I just made touching exactly the same point. We call them adjacent angles, and adjacent angles will normally add up together. If it covers the whole entire straight line, it will always equal to 180. All right, if it's off the same straight line, if all the angle together off the same straight line together will equal to 180 degrees. All right, I'm not going to talk about opposite angle. It's not a very good wording. The word complementary, two angles are considered as complementary if the sum of their measure is actually 180. So I'm gonna kind of highlight. In geometry, whenever you hear the word complementary, that means they have a sum of 90 degrees. So what will be what will be complementary or complement? What's complement of 30 degree? Well, the word complement means two angles together is 90. So if one of them is 30, that means the complement of 30 degree got to be 90 minus 30, which most people know is 60. I agree with that. But the key part is because the sum is actually taking the total minus what the other one is, okay? Because now if I will change this to what is complementary angle of x degree, what would be the complementary angle of x degree? Well, to find it, it's the same thing as what we just did with a 30. The total is 90, you minus what the other angle is. So complementary of x degree got to be 90 minus x. So that's putting a little bit of algebra into geometry. All right, same thing with supplementary. Supplementary means two angles that have a sum of 180 degrees. So in a minute, when we do some example, whenever you see supplementary, okay, remember the two angles together is 180. All right, earlier I showed you the perpendicular lines. You got to have a right angle symbol in the pictures. And to be perpendicular, you got to use this symbol right here in your direction. So why do we have all these symbols? Mathematicians are lazy. They're gonna create symbols to actually, rather than write out the whole word perpendicular, it's easier to actually use symbols. And rather than talking about the opposite angles, I like to show y'all something called the vertical angles. Okay, if two lines intersect, then there's going to be two pairs of vertical angles. Okay, that will be created. In order to think about vertical angles, you got to see two lines intersecting at one point. Okay, that's the key of it. All right. If the two lines intersecting at one point, then two pairs of vertical angles are formed. Vertical angles are opposite to each other. Okay. So I like to tell students is the angles that faces each other. Angle 1 faces angle 4. So these two angles are vertical angles. And vertical angles are always congruent. So here congruent means they have exactly the same angle measure. All right, angle 2 faces angle 3. So those two angles are vertical angles. Okay, and they are congruent. So quickly, for example, find angle number 3. Now, angle number 3 is all the way up here, okay? Angle number 3 is up there. So when we do problem like these, it's a lot, we got to use the concept that we learned from doing the conversion. We know what we want at the end. So we need to work our way back, okay, to the given. We need to work our way back to the given. So in order to find angle number 3, agree or disagree, angle number 3 is inside this triangle. All right, it will be great if I can figure out angle number 2. Why? Because if I know angle 2 and the 53 given, by being inside the triangle, we know triangle has 180 degrees. So when I find angle number 2, to get to number 3, all I had to do is take 180 minus angle 2 and minus that 53 degree. That's how I actually get to angle number 3. Well, to know angle number 2, I need to know angle number 1. Well, angle number 1 and angle number 2, as you can see, two lines intersect at one point. If two lines intersecting at one point, then we can think of the vertical angles. So angle 1 and angle 2 are vertical angles. So if I know angle 1, I get angle number 2, then I can find angle number 3. All right, so how do I get to angle number 1? Well, angle number 1 is inside of another triangle. So to find angle number 1, all we got to do is take 180 minus 42 minus 62. Okay, because the total is 180. I thought I turned on my calculator earlier. Let me save this before I forget. Well, let's see what angle 1 is. So that's 180 minus 42 minus 62. So real quick, angle 1 is 76 degrees. So since angle 1 and angle 2 are vertical angle, they are congruent. So that tells me angle number 2 is 76. Oh, Lord. So that means angle 3 will simply be the 180 minus the 76 minus the 53. All right, so that's not too hard. So I brought this prop, I showed this example so we can kind of illustrate that some of the things that we learned from the conversion, okay? Like I said, all those conversion problems, you can actually just Google it and tell you the answers. But by showing the student how to, how the process works to get to what you wanted, it kind of helped us with geometry a little bit. All right, it's 51 degree. All right, let's try this example. You got to read this carefully, okay? In the figure below, okay, this is a ray. See, there's only one arrow, the other one don't. In the figure below, ray VR. So when you do your homework in the test, you want to kind of draw it out a little bit so you can actually write down what these angles are. VR, from V to R, ray VR. I'm gonna put this in red. This VR bisects angle from T to V to S. So the word bisect means cut them exactly in two half. All right, so this red ray bisects, okay, my angle T to V to S. And VQ bisects angle UVS. All right, I'm gonna use another color. So VQ bisects angle from U to V to S. If angle number 2 is 60 degree, this is 60 degree. Find angle 1. All right, where's angle 1 at? Angle 1 is actually right here. Now, so here we go. Here we go. See this right angle symbol right here? This 90 degree symbol here tells me that the other side of angle number 2, that is actually 30 degree. Now I don't quite need it, but I just want to point that out. All right, but the problem did tell me that this ray V to Q bisects the entire angle U to V to Q. I'm sorry, U to V to S. So this blue line bisects this entire angle. So if half of this big angle is 60, and we know this blue line already bisected, that means angle 1 got to be also 60. Okay, I hope that makes sense because let's ignore the other side where I drew in red. If V to Q is actually bisecting the big angle, so that means these two are exactly the same. Well, if 2 is 60, then 1 is actually what? 1 is actually 60 as well. The reason why I point out the other side of angle 2 is if this side is 30, that means the big angle from T to V to S, okay, that big angle has been bisected by the ray VR. So that means the other side of this 30 also got to be 30 as well. Okay, that's how you actually think about all these pictures, you know, what other number can be. All right. So let's try it in terms of using equations or expressions. In a figure below, QM bisects the big angle OQN. O to Q to N. This big angle, all right, QM bisects it, and QL bisects the big angle P to Q to N, which is right here. So this big angle right here is being bisected by QL. All right. If P to Q to N is 146 degrees, so this big angle right here is 146 degree, and angle L is right here, sorry. L to Q to N. So this tiny part, L to Q to N, this part of that part of this big 146 degree is going to be 5r plus 18 degree. Find r. Well, how do I find r? What do y'all think? How can I use the 146 and bisect to help me set up some sort of equation so I can find r? There are two ways we can do it. Well, three ways, I guess.
Can you divide the 5 on both sides?
No, not yet. We gotta have an equation first. What should my equation be? If I would tell you that big angle is 146 degree, and that big angle has been bisected, and one of them is 5r plus 18.
Oh, don't you gotta subtract 18 on both sides?
No, ma'am. Too early.
You don't have a.
We don't even have an equation. Yeah, we need an equation. The 146. I mean, would you agree the 146 is actually 2 of this 5r plus 18? What should be on the other side? 5r plus 18, right?
Mm-hmm.
Remember, it's being this ray bisected. So if one side is that angle, the other side is also the same thing, just like the previous problem. Or you can say, because the 146 has been bisected, that means exactly what is this angle right here? What is each one of these angles?
73.
That's right. So the 5r plus 18 is one of the 73. That's what we needed to actually write out the equation. So one of these 5r plus 18 angle is what? Is 73 degrees. You know what I'm saying? That's how you actually set up the equation. That's the easiest one. Now we can actually say, all right, let's move now to solve for r, my variable term is positive. All right, so I'm gonna let it stay there. I'm gonna move my positive 18 to the other side. Positive 18 moved to the other side, become negative. So that will give me 73 minus what? 18, right? So that's 5r equal to 55. So my r is equal to what? 11. Okay, we don't need to know what the angle is. You don't have to substitute back because we already know that one of the angle is 73. So the problem just want me to find r. All right. Let's try this, okay? If this angle and that angle are complement to each other, find the measure of the angle. So this time we actually need to find the actual angles. Well, what did we say earlier about complementary? Complement means the two angle has a sum, this angle and this angle have a sum of what? 90 degrees. There you go. That's how we set up the two equation. I went ahead and took out the parentheses for the two terms that's inside because I'm not actually I'm not actually going to do any distribution, so I don't really need those parentheses. All right, so combine like terms, 13 plus 19 give me 32x. Negative 13 plus 7 is negative 6 equal to 90. If I move the negative 6 over, just like we did at the beginning of the semester, this is going to be 32x equal to 96. Divide both sides by 32. X equal to 3. Now, I'm not done here, okay? Because the question is asking for the measure of the angles. So I need to plug it back in. And I'll probably just need one of them. because the other one I can subtract from 90. 13 times 3 minus 13. So one angle is 39 minus 13, right? Is 26. So the other angle got to be 90. Remember, the two angles together are 90. So if one of them is 26, the other one got to be 64. There you go. These are my two answers. All right, so this is how we kind of connect algebra that we learned before with the geometry. All right, this is a little bit of translation. So I do want y'all to continue to remember how to do translation. Two angles are supplementary to each other. So that tell you that the two angles, whatever these two angles I'm going to translate together is going to equal to 180. All right, one angle is 50 degrees more than, okay, so here we go. The translation word more than tell me I got to translate this sentence. From this sentence, we get our two items that we need to translate. So what do we call the two items? One angle and what? The other angle. All right, and which item, out of the two items, which one is listed at the end of the sentence? That will be the other angle. So we like the other angle to be X. We go back, translate for that one angle. Now one angle is 50 degree, 50 degree. More than means plus, plus who? The other, which is X. So this whole equation from the very beginning already told me that one angle plus another or plus the other angle together will be 180. So now I'm gonna purposely put this plus sign in red. This plus sign means the two will add up together equal to 180. So what I just translate for the one angle is 50 plus X plus the other one X. All right, so now combined like term, this is 2X plus 50 equal to 180. With the positive 50 over, that tell me this is gonna be 2X equal to 130. So divide both sides by 2, X is equal to 65. So we already labeled that the other angle is 65 degree. So, and the other angle is X. So the other angle is 65 degree. All right, 50 plus the X I just found, which is 65, will tell me that's 115 degree. Those are the measure of both angles. All right. So just a little bit of algebra mixed with some of these basic concepts of lines and angles. Okay. So, so that will conclude our topic number 17. All right. Thank you for watching.